Hi everyone, in this lesson we'll look at how to determine a quadratic equation given its roots. So let's just review a couple things about quadratic functions. So there's three different ways that are convenient to write a quadratic function, or there's three different forms that are convenient to write a quadratic function in. The first is standard form, where we have the equation written in the form f of x is equal to ax squared plus bx plus c, where a is not equal to 0, because if it were equal to 0, we would get a linear function. The next is vertex form. In vertex form, we have f of x is equal to a times x minus h squared plus k, where h comma k gives us the vertex of this function. Lastly, we have factored form. And in factored form, we write the function as f of x is equal to a times x minus r times x minus s. Now, what's convenient about factored form is that we can tell what the zeros of the function are just by looking at r and s. So r and s are the zeros of this quadratic function. Now let's go ahead and we'll do an example here. So here we're told find the equation in factored form for a family of quadratics with the given roots 4 and 2. So first off, we have that our function in factored form is f of x is equal to a times x minus r times x minus s. That's the function written in factored form, where r and s are the zeros of this function. So here we have that r is equal to 4, because that's one of the zeros, and s is equal to 2, because that's one of the other zeros. So our equation in factored form for the family of quadratic functions with the zeros 4 and 2 would be f of x is equal to a times x minus 4 times x minus 2, where all that I've done is I've just plugged in r and s for, 4 and 2 for r and s in this equation. So now it just wants us to sketch each family. We just have to show at least 3 members. So let's consider first where a is equal to, let's consider where a is equal to 1. Well, where a is equal to 1, our function would be f of x is equal to x minus 4 times x minus 2. Now, I can graph this by finding the vertex. I also know that the zeros are at 4 and 2. So let's go to 4 and we'll plot one of the zeros there. And 2 is our other 0. So I'll put a point there. To find the vertex, well, the vertex is exactly halfway between 4 and 2, which is just 3. So that's the x value of the vertex. To figure out what the y value of the vertex is, we can just do f of 3, which is equal to 3 minus 4 times 3 minus 2, which is equal to negative 1. So the y value of the vertex is negative 1. The x value is 3. So we can go to 3 comma negative 1, put a point there. And now we can follow the step pattern of f of x is equal, or we can follow the step pattern 1, 3, 5, 7, 9, because, etc., because a is equal to 1. So we've already got the first step. We go over 1, up 1, then over 1, up 3, and over 1, up 5. So that'll be another point on our quadratic. We can reflect these points about the axis of symmetry to plot our quadratic. And that's our function, that's our function f of x. Okay, next let's, since it says that we have to show at least 3 members, well, right here we've got 1 member of the family of quadratics. So let's find another. Let's consider a is equal to, 2. If a is equal to 2, we have f of x is equal to 2 times x minus 4 times x minus 2. And the x value of the vertex, again, is going to be halfway between the zeros, and the zeros are 4 and 2. So we'll have the same x value for the vertex. To figure out the y value of the vertex, we can just do f of 3, which is equal to 2 times 3 minus 4 times 3 minus 2. Well, this is just equal to negative 2. So the vertex is located at 3 comma negative 2, which is, let me use a darker color here. Let's use blue. Let's stay with green, actually. So 3 comma negative 2 is this point right here. Now we can, and we know that our graph passes through the zeros, 4 and 2. Next, we can follow the step pattern. So the step pattern is going to be, it would be 1, 3, 5, 7, 9 for f of x is equal to x squared. So for f of x is equal to 2 times x minus 4 times x minus 2, we're going to just multiply the same step pattern by 2. And we get, it's normally 1, 3, 5, 7, 9. So this is going to be 2, then over 1 up 6. So 2, then 6. And then the next point is going to be off the graph. We can reflect this point about the axis of symmetry. And that function is, actually, let me change the, let's change the name of this function to be, let's change it to be g of x. And this would be g of 3. So now we can graph f of x, and then we'll graph g of x as well. So there's 2 members. Now we've got to graph one more member. So let's do, let's graph, let's say a is equal to negative 1/2. So let's call this h of x. So h of x would be equal to negative 1/2 x minus 4 times x minus 2. The x value of the vertex halfway between the 2 zeros, and the y value, to figure out the y value of the vertex, we're just going to do h of 3, which is equal to negative 1/2 times 3 minus 4 times 3 minus 2, which is equal to negative 1/2. So we can plot negative 3 comma negative 1/2. Oh, sorry, this should be positive 1/2. Sorry, guys. Because 3 minus 4 is negative 1, 3 minus 2 is 1. Negative 1/2 times negative 1 is positive 1/2. So this is positive 1/2. So we should put a point here. And then we know that the zeros are also on our graph. And then we can follow the step pattern because our a value is negative 1/2. So we can, our first step would be negative 1/2, and then our second step would be negative 1.5, followed by negative 2.5, followed by negative 3.5. And then our next point is off the graph. And to graph this quickly, we can just reflect these points about the axis of symmetry. We get a point there, and a point there. Lastly, we'll just draw a smooth curve through all of these points. And we're done. We'll label the function as h of x, and now we have the family of quadratics where the zeros are 4 and 2, and we have at least 3 members of the family graphed on the grid. So the equation for the quadratic functions with given zeros 4 and 2 is f of x is equal to a, because a can be any real number except for 0. So where a is not equal to 0. And we can really get every quadratic function that has zeros 4 and 2 on this grid, but we were only asked to sketch 3 of them. So that concludes this video, and we'll see you in the next one.